Good morning, dear students. Yes. Okay. In the last class, we have started with the chemical reactions, right? So we have started with the nucleophilic addition reaction. So you can okay. So in the last class, we have started with the nucleophilic addition reactions. Okay. So nucleophilic addition reaction of HCN, right? So aldehyde and ketones, they react with hydrogen cyanide to yield cyanohydrin. So these reactions we have seen. So some of the addition reactions, so nucleophilic substitution reaction. So we have seen the mechanism also. So nucleophile will attack the sp2 hybridized carbon. Okay. So which is carbonyl group is a polarized bond. Okay. So because of the polarized, because it is a polar bond, there will be development of charges. So partial positive charge will be developed on the carbon and partial negative charge will be developed on the oxygen. So as a result, so it undergoes a slow step where sp2 hybridized carbon will turn into a tetrahedral, that is a carbon with the sp3 hybridization with a tetrahedral geometry, right? So in the next step, what is happening? The hydrogen, in the first step, the oxide ion, okay, alkoxide ion, it takes up the proton and it forms up a your product. Okay, so it forms an addition product. Fine. So this was the what I we have seen. So basically, we have seen the addition nucleophilic addition reaction of hydrogen cyanide, then sodium hydrogen sulfide, and addition of alcohols. Right. So alcohols, when you react it with your aldehyde, you get hemiacetyl. Then hemiacetyl again, when you react with one more molecule of alcohols, you get acetals. Okay, not hemiacetals, it is acetals. So these are the uh, nucleophilic addition reactions. So now let us see with ketones. Okay, if you have a ketone, how it will react. Okay, so we have seen in the last class up to add only up to the aldehydes, right? How aldehydes react with alcohols and they form acetals and hemiacetals respectively. So now let us see with ketones how they react with ketones. Okay. Okay. So here you can see this is a ketone. Okay, both are the R group. Now ketone, here we have taken a glycol. Okay, ethylene glycol group is there. Now ketone, when it reacts with ethylene glycol under same condition, that is in the presence of dry HCl gas, you get ethylene glycol ketal. Okay, so whenever you have aldehydes and aldehydes, when it reacts with your alcohol, you get hemiacetals. Okay, one molecule of alcohol, when it reacts with alcohol, one molecule of alcohol, you get hemiacetal. Then this hemiacetal again, when it reacts with one molecule of alcohol, you get acetals. Okay, remember this. But when you react the ketones with your alcohols, okay, you have a ethylene glycol. In ethylene glycol, you can see there is a two OH group. So what happens when you pass HCl gas? This OH group, what you can see, okay, it forms like water molecule H2O, and this is left. So water molecule is left, and what you get is RC, okay, RC, then O, CH2, CH2. Okay, so you get a ethylene glycol ketal. You get ethylene glycol ketal. Okay, you get what? Ethylene glycol ketal. So like this, so this O minus, so it will get polarized and you will get the ethylene glycol ketal group. So this is another reaction where it undergoes a addition nucleophilic addition reaction. Next is with addition of ammonia and its derivative. Okay, again ammonia. So what you have here? So you have a carbonyl group and ammonia is what? NH3. So NH. Okay, so what is happening here? So one of the lone pair of electrons from the nitrogen will attack this carbonyl carbon and the bond will get polarized. Okay, so what will happen? What will happen? So the bond formation will be like this. So this O, okay, your N, then H. Fine. So this OH. So this EHN goes and combined with this oxide ion and it forms OH. Now this will undergo what? Rearrangement to give you C. Okay, here it moves as a water molecule. Okay, it moves as a water molecule and it gives you what? It gives you a imine system. Okay, it gives you a imine system. So it gives you imine. So whenever a nucleophilic addition reaction takes place of ammonia with carbonyl group, it gives you a imine system. Okay, it gives you a imine system. So these are some of the nucleophilic addition reactions which you have to keep in mind. Okay. So some more reactions. Okay, so what we have discussed just now was the imine system. Just now, this was the that one. Okay, carbonyl group. So carbonyl group reacting with ammonia. Okay, there will be loss of water molecule, and what you get is the imine. Right, C double bond NH is nothing but your imine system. Okay, it is your imine system. Then carbonyl group, when it reacts with a primary amine means what? Now NH3 is there. So one of the hydrogen is replaced by R. So it is a primary amine. So what you will get? You will get instead of your hydrogen, here you will get your R substituted imine. So you get a substituted imine. So whenever you have a carbonyl group and you react with a primary amine, how you get primary amine? One of the hydrogen is replaced by a alkyl group. One of the hydrogen is replaced by the alkyl group, then you get what? You get a substituted imine, and this is called as the Schiff's base. Okay, it is called as the Schiff's base. Then second one, when the carbonyl group reacts with a hydroxyl amine. Okay, hydroxyl amine means again what? So your NH3 is there. Okay, so one of the hydrogen is replaced by OH group. So it results into hydroxyl amine. Hydroxyl amine. So when one of the hydrogen is replaced by OH group, it results into hydroxyl amine. Now this hydroxyl amine, okay, when it reacts with your carbonyl carbon, what you get? You get a oxime. Okay, again you get what? C double bond N O H. So this is called as oxime. Okay, this is called as oxide. Then next is when your one of the hydrogen group is replaced by NH2. Okay, it results into hydrazine. Okay, it results into what? Hydrazine. So what you get? The obtained product is C double bond N NH2. So this is called as hydrazone. Okay, it is called as hydrazone. Okay, so please remember this. So whenever, so these are the derivatives of ammonia. So ammonia, when it reacts with carbonyl carbon, you get imine system. Okay, you get a H here. When one of the hydrogen is replaced by your R, you get what? You get a primary amine. Okay, you get a primary amine, and the resulted product is what? You get a substituted imine. Okay, that is called as a Schiff space. Then one of the hydrogen is replaced by what? OH group. Then it is a hydroxyl then it is hydroxylamine, and the product obtained is oxime. Then when one of the hydrogen is replaced by NH2 group, then it is hydrazine, product obtained is hydrazone. Okay. Then one of the hydrogen is replaced by what here? A phenyl ring. Okay, replaced by phenyl ring. Then it is phenylhydrazine. Okay, it is phenylhydrazine. This phenylhydrazine, okay, when there is a loss of water molecule, you get phenylhydrazone. Okay, phenylhydrazone. So these are some of the derivatives of ammonia. So whenever ammonia and its derivatives are there, so respective products are formed. Is it clear? Please note it down. Very important. Please note this down. The very important reaction. These are some of the important reactions which we are discussing now. So nucleophilic addition reaction is one of the important reactions. Okay. So these are things you have to remember. Okay, they might ask you, so how, so with the different derivatives, okay, with the different derivatives, how you get different products. They may ask you how you get oxime. Okay, you have to tell carbonyl group when it reacts with a hydroxylamine, you get oxime. So like that, you have to remember all these products and the reactants what you're using. So whenever you are using primary amine, we'll get substituted imine. Whenever you are using hydroxylamine, you get oxide. Whenever you use a hydrazine, okay, when one of the hydrogen is substituted by NH2 group, then you get hydrazone. And when one of the this what hydrogen is replaced by a phenyl group, you get phenyl hydrazone. So these things you have to remember, very important. Okay, so mark this as important. That is derivatives of how the addition of ammonia and its derivative takes place. Very important, asked during exams. Okay, all these are very important. Okay, we'll go for the next one. Okay, next you have again. So here, what is happening here? So again, ammonia derivative is there. So one of the hydrogen, okay, one of the hydrogen is replaced by a phenyl derivative with a phenyl derivative that is 2 1 sorry 2 4 dinitrohydrazine. Okay, so NH group. So when one of the hydrogen is replaced by this particular group, that is 2,4-DMP. Okay, so when carbonyl group, it reacts with what? If it reacts with a okay, if it reacts with a 2,4-dinitrohydrazine. Okay, so when a carbonyl group, when it reacts with a 2,4-dinitrohydrazine, you get what? 2,4-dinitrophenylhydrazone. So this is 2,4-dinitrophenoylhydrazone. Okay, is it clear? So 2,4-dinitro derivatives are yellow color, orange or red. Okay, useful for characterization of aldehydes and ketones. So the 2,4-DEMP test, it is usually used to distinguish whether they are aldehydes or ketones. Okay, so respective color is shown by this particular test. So these are some of the important tests. So mark this also important. So this is asked question. Okay, so what will be how the product is formed? They will ask you. Okay, so carbonyl carbon when it reacts with 2,4-dinitrohydrazine, what is the product formed? Right. So what is happening in each step? What you can see that there is a loss of water molecule. Okay, from the previous all the derivatives, you can see that there is a loss of water molecule, right? You can see there is everywhere. You can see the loss of water molecule here, right? So with the loss of water molecule, it is forming the product. So this is the byproduct which is formed. So here also you can see when carbonyl carbon when it reacts with the 2,4-dinitro phenylhydrazine. Okay, you get a 2,4-dinitrophenylhydrazone. Okay, next here this is a semi-carbazide. Okay, semi-carbazide. So when one of the hydrogen, okay, NH2. So when one of the hydrogen is replaced by NHC double bond ONH2. Okay, so when one of the hydrogen is replaced by NHC double bond O NH2, okay, which is called as a semi-carbazide, okay, the obtained product is called as semi-carbazone. Okay, semi-carbazone. So the obtained product is what? Semi-carbazone. Fine. So these are the products which are obtained. Is it clear up to here? Yes. Any doubts up to here? Yes. Any doubts? So these are the reactions where you can see how the ammonia and its derivatives, okay, how they react. Okay. So these are the different products you have to remember. So they may ask you, how they will ask you? They'll not give you carbonate. Okay. Suppose I'll ask you a question. Suppose my question is that, okay, suppose my question is, so based upon the previous all knowledge, okay, now you apply. Suppose I have a acetaldehyde. So I'll give you a particular aldehyde and then I'm going to react it with the hydrazine. This is what our hydroxyl amine. Okay, our hydroxyl amine. So what product you are going to get with this? Yes, students, what products you are going to get when you react your acetaldehyde with hydrazine, hydroxylamine? H2O will go. Okay, H2O will go. So what will form? CH3, C, then double bond, NOH. Right. So and this is H. Is it so? What is the name? What is this product form? It is a oxime. So it is a acetaldoxime. Okay, acetyl oxide. Is it clear? So important. Okay, so acetaldehyde, they'll give you like this question. Acetaldehyde, if it reacts with hydroxylamine, what will be the product obtained? Okay, what will be the product obtained? So there is a loss of water molecule H2O. Okay, H2O. So what you will get? CH3CH double bond NOH. So this is a oxide. Okay. Next question. Is it clear? So next question. So how does benzaldehyde react with hydrazine? So let's take a benzaldehyde. So benzaldehyde is C6H5 C double bond OH. So this is your benzaldehyde. When it reacts with NH2, so it reacts with the hydrazine. So benzaldehyde, when it reacts with hydrazine, okay, what will be your product obtained? Yes, students, what will be the product obtained? Just remember to remove the oxygen water molecule like this. Okay, what will be the product obtained? So there is a loss of water molecule. So it will be C6H5 CH double bond N NH2. Right. So this is what it is, a benzaldehyde. Okay, it is a benzaldehyde hydrazone. Okay, you get a hydrazone. So when you react with hydrazine, okay, your benzaldehyde, it reacted with what? Uh, Hydrazine. What you are going to get? I'm going to get a benzaldehyde hydrazone. Okay, benzaldehyde hydrazone. Next, one more question. Take benzaldehyde again. CH benzaldehyde. react it with your this semi-carbazide. Okay, NH2, NH, C double bond O, NH2. Okay. React with the semi-carbazide. Tell me the product. Now this you have to tell. So you have to remove just the water molecule and see what you're going to get. So write the remaining thing. So C6H5. Okay, C, H, double bond, N, NH, C double bond O, NH2. Okay, so what is the compound name? So this is a benzaldehyde. This is a semi-carbazide. And this is your benzaldehyde semi-carbazone. Okay, is it clear? So whatever the products are correct, is it understood? So whenever ammonia and its derivatives, whenever they react, there will be loss of water molecule, and rest all it will be the same. Okay, after losing the water molecule, the double bond will be connected to this nitrogen over here. So NOH, so oxide. So respective products are formed. With hydrazine, hydrazone are formed, and with amines, that is hydroxylamine, oxime is formed. So we have seen the different reactants. Okay, with primary amine, we get a substituted imine. With hydroxylamine, we get a oxime. With hydrazine, we get hydrazone. With phenylhydrazine, we get phenylhydrazone. With the 2,4-dinitrophenylhydrazine, we get 2,4-dinitrophenylhydrazone. And with semi-carbazide, we get semi-carbazone. Okay, so these are the different products with different reaction. Is it clear up to your students? So I've given you different examples also. Okay, so that it will be more clearer to you. Is it clear how the reactions can be asked? Yes. Is it clear? Okay. Next is reduction. Okay, next is reduction. So whenever you have aldehydes and ketones, okay, so aldehydes and ketones, what will happen to aldehydes and ketones? So aldehydes and ketones, they are reduced to primary and secondary alcohols, okay, by using sodium that is your borohydride. So by using sodium borohydride, your or you can use lithium aluminum hydride. So these are the two reducing agents which can be used in reduction of your aldehydes and ketones to primary and secondary alcohol. So if you have a aldehyde, okay, and if you react with any of this reagent, okay, I'll do reduction, you get a primary alcohol, okay, and when you have a ketone, and if you do a reduction on this, you get what? A secondary alcohol. Okay, so you can use the reducing agents like sodium borohydride or lithium aluminum hydride. Okay, or you can use catalytic hydrogenation also. Catalytic hydrogenation means what? In the presence of H2 platinum, H2 palladium, or H2 nickel. So these are the this is the meaning of catalytic hydrogenation. Hydrogenation means we are adding hydrogen molecule. We are adding what? Hydrogen molecule. How we are adding this hydrogen molecule? In the presence of the platinum, palladium, or nickel as the catalyst. Okay. So by using this particular catalyst, we are going to what we are going to do? We are going to do the hydrogenation. Okay. So aldehydes and ketones, what is happening? They are reduced to primary and secondary alcohol by using sodium borohydride or lithium aluminum hydride, or we can do catalytic reduction. Okay, hydrogenation. Fine. So let us see the general reaction. So suppose this is our a carbonyl carbon. If we do hydrogenation, okay, in the presence of that is your lithium aluminum hydride. Lithium aluminum hydride is a reducing agent, but it is a costly reducing agent. So what will happen? It will be reduced to alcohol. Okay, it will be reduced to alcohol. So this is the reaction. So aldehydes, that is your carbonyl group. Here they have not specifically mentioned it is whether it is a aldehyde or a ketone. So any carbonyl group, when we do a reduction on that, okay, when we do reduction on that, reduction is nothing but what? Addition of hydrogen, okay, addition of hydrogen or removal of oxygen. That you have to remember, removal of oxygen. So whenever we are doing reduction, okay, on a carbonyl group, what we are going to get? We are going to get a alcohol. Now we will see separately. Now, if we have aldehydes, okay, we have aldehydes and we are doing what? We are doing reduction. Reduction means what? Addition of hydrogen or removal of oxygen. Okay, we are going to take solvents such as your tetrahydrofuran or ether. So these are the solvents which we can use. That is tetrahydrofuran or ether. We get what? Primary alcohol. Just now we have told now aldehydes when it reacts when we do a hydrogen that is we are doing a hydrogenation or when we are doing reduction we are going to get primary alcohol. We are going to get what? Primary alcohol. So what is happening here? So RC, so here one hydrogen is added, here one hydrogen is added. So what do you get? RCH2OH. So after removing this double bond, okay, after removing this double bond, across this double bond, you can see like that, across this double bond, one hydrogens are added. So you get a primary alcohol. Secondly, when we have a ketone, we have a ketone. Ketone means what? Both are R group. Here you can see one is a R group, another is a hydrogen group in your aldehydes. Now, ketones, when it reacts with sodium borohydride, that your borohydride, okay, or you can take lithium aluminum hydride in the presence of tetrahydrofuran or ether, you're going to get what? Secondary alcohol. You're going to get secondary alcohol. Okay, so again, across the double bond, hydrogens are added. Okay, across the what? Double bond hydrogens are added. What you get? A secondary alcohol. Okay, is it clear? Is it clear? Is it clear about reduction? So what is reduction? Addition of hydrogen or removal of oxygen. So what we are doing? Whenever we have a carbonyl group, when we are reacting, when we are doing reduction on that, we are going to get a alcohol. Now, respectively, when we have aldehydes, it will give you primary alcohol. When we have ketones, we will get a secondary alcohol. Okay. Now, I want this. Okay. I'll give you example. Okay. You have to tell me the product. Now, acetaldehyde is there. So this is acetaldehyde. Now, I'm going to do what? I'm going to do reduction on this in the presence of lithium aluminum hydride. So what will be the product obtained? And one more, I'll take a ketone. So this is a acetone. So let me do a reduction on this. Okay. Let me do catalytic hydrogenation. Okay. Tell me the products obtained, students. So with the acetaldehyde and acetone. Yes. What is the product obtained? Across this double bond, add hydrogens and tell me the product. Yes. Anybody? No one? I've told you, no, your CH3 should be added. So it is CH3. Let me write it this side. So CH3, CH. Okay. Now across this one hydrogen and here one hydrogen. Okay. So what is the name? It is a ethyl alcohol. Yes, it is a ethyl alcohol. Now here CH3, CH, OH, CH3. Yes, what is the name, students? It is a, how many carbons are there? Three carbons. So it is propane, 2 all, or it is isopropyl alcohol. Isopropyl alcohol. Is it clear? Yes. Why there is no response? Is it clear? Okay. So this is with respect to reduction of alcohols. So when we do reduction, okay, on a carbonyl group, we are going to get alcohols. So if you have a aldehyde, you get a primary alcohol. If you have a ketone, you get a secondary alcohol. So why we are using lithium aluminum hydride and sodium borohydride? So here, when we talk about lithium aluminum hydride, it is a strong reducing agent. When we talk about sodium borohydride, it is a weak reducing agent. So when we are using this two particular reducing agent, we are going to use solvents such as THF, that is a tetrahydrofuran, tetrahydrofuran. Okay, THF is tetrahydrofuran, or we are going to use ether as a solvent. Same way with respect to sodium borohydride also, THF or ether can be used as a solvent. Then lithium aluminum hydride, it is used for reductions of aldehydes, ketones, carboxylic acid, acid chlorides, nitriles, esters, and nitrocompounds. And sodium borohydride, it is used for reduction of only aldehyde, ketones, and acid chlorides. And lithium aluminum hydride, what happens? So the conjugate double bond gets reduced. So whenever you have a conjugate double bond, okay, so it gets reduced. But sodium borohydride, it does not get reduced. Then lithium aluminum hydride, what happens? Double bond, the isolated double bond does not get reduced. Same way is with respect to sodium borohydride also. So what you have to remember is that it is a strong reducing agent. Sodium borohydride is a weak reducing agent. Okay, so this is the important thing that you have to remember. Fine. Next is we are going to do reduction to hydrocarbons. Next is what? Reduction to hydrocarbons. So what is happening here? Both the aldehydes and ketones, they are reduced to hydrocarbons. Okay, they are reduced to CH2 group. They are reduced to what? They are reduced to hydrocarbons. So how it can be reduced to hydrocarbons? So first, very important name reaction is Clemenson's reduction. Very important name reaction is Clemenson's reduction. Mark this as important. Mark this as important for 2 marks. So they may ask you, explain Clemenson's reduction. Okay. In Clemenson's reduction, what is happening? Your carbonyl group is reduced to your hydrocarbons. Okay. Remember this. Carbonyl group is reduced to hydrocarbons. So what is happening here? Just see, your aldehydes or ketones, both can be taken. Okay, in this reaction, so we have taken generally a carbonyl group here. Okay, we have taken generally a carbonyl group. So aldehydes or ketones, you can write here aldehydes or ketones. Okay, so they both. So in this reaction, both the aldehydes and ketones, they are treated with zinc amalgam. What is ZnHg? ZnHg is zinc amalgam in the presence of concentrated HCl. Okay, in the presence of concentrated HCl, okay, we are going to get what? We are going to get hydrocarbons. We are going to get hydrocarbons. So what is happening? Aldehydes or ketones. Okay, we are going to treat it with the zinc amalgam in the presence of concentrated HCl. We are going to get hydrocarbons. Okay, so let us give an example. So I want answer from you all now. Don't sit idly there. So tell me the answer. So we are going to do Clemenson's reduction. So you have to explain. So when they ask you, explain Clemenson reduction. So you have to write the explanation, you have to write the general reaction, and you have to write the example. Okay, and names should be mentioned below. Okay, so what is the reagent? They can ask you the question. What is the reagent used in Clemenson's reduction? What it is? Zinc amalgam in the presence of concentrated HCl. So zinc amalgam in the presence of concentrated HCl. Yes, can you tell me what will be the product, students? What will be the product? What will be the product? Yes, anybody? What will be the product? We are doing reduction. Your oxygen will be replaced by hydrogens. Okay, you are oxygen. You have to replace by hydrogen molecule. Yes, write it. What it can be? CH3, CH3. So it is what? It is a ethane. Okay, it is a ethane. Okay, it is a ethane plus H2O is left. So whatever, so two hydrogens will add up here, and whatever the remaining two hydrogens are there, so these two hydrogens will make up a water molecule. Understood? Yes. So this is a Clemenson's reduction. So what is happening? Your carbonyl group, that is aldehydes or ketones, can be reduced to hydrocarbons in the presence of zinc amalgam in the presence of concentrated hydrochloric acid. Okay. This we are going to get what? We are going to get a ethane plus water. Okay. Fine. Next, one more. Shall I give you one more? Now I want the answer from you. Okay. So that was with respect to aldehyde. Now let me give you a ketone. So let me give you a ketone. So take ketone, react it with four molecules of four hydrogen atoms in the presence of zinc amalgam. Okay, zinc amalgam and concentrated HCl. What we are going to get? Acetone. When it reacts with zinc amalgam in the presence of concentrated HCl. Yes. So this oxygen will be okay. Two hydrogens are added. It will combine with the two hydrogens again. And here two hydrogens are added. So what would be a product of it? And here this will combine with hydrogen. So once you will get H2O, okay, H2O, and here CH3, C, CH3, and CH2. Is it? Got it? So what is the product? It is a propane. It is a propane and water molecule is eliminated. Got it or no? Yes. Okay, fine. So this was about the Clemenson's reduction, very important reduction. Okay, name reaction. Next is Wolff-Kishner reduction. Important again. Mark this as important. Important. Okay, so in Wolff-Kishner reduction, what we are doing? Aldehydes and ketones, they are treated with hydrazine. NH2, NH2 is what? Hydrazine. Okay, we are going to treat our aldehydes or ketones in the presence of hydrazine. Okay, again, followed, we are going to heat it with sodium or potassium hydroxide. Okay, we are going to heat it further in the presence of sodium or potassium hydroxide in the presence of ethylene glycol. Again, we are going to get what? Hydrocarbons. We are going to get what? Hydrocarbons. So your aldehydes or ketones, okay, what is happening with aldehydes and ketones? They are treated with hydrazine. Okay, this hydrazine is further heated with potassium hydroxide in the presence of the solvent like ethylene glycol to yield you hydrocarbons. Okay, and so here you can see. So what will be the eliminated product here? So your O will combine with hydrogen. Okay, oxygen will combine with this. So this we have seen no in derivatives of so here C carbonyl group plus H2 and NH2. Okay, so what will happen here? This will be so it forms double bond N NH2. So it forms the imine system. Okay, hydrazine system. Then what you are going to get? Yes, what we are going to get? You get the hydrazine. This hydrazine, further we are going to treat it with what? Potassium hydroxide in the presence of ethylene glycol, and we are going to heat it to give you CH2. Okay, we are going to get a hydrocarbon. Fine. So let me give you example. I want the, yes. Tell me the answer now. Yes, tell me the answer for this. So this is a benzaldehyde. Yes. What will be the product obtained? So just see, H2 will be removed out. So what you'll get? You get first yes. Is it? Yes, is it? This further we are going to treat it with what? Potassium hydroxide in the presence of ethylene glycol. We are going to heat it. What we are going to get? So across this double bond, again we are going to add H2. So this becomes toluene. Okay, you get a toluene. So this is the what? Uh, Hydrocarbon. Okay, so this is the hydrocarbon which we get in Wolff-Kishner reduction. Okay, is it clear? Yes. So Clemmensen reduction. What is the reagents? Zinc amalgam in the presence of concentrated HCl, we get hydrocarbon. And Wolff-Kishner reduction, aldehydes or ketones, we are reacting with hydrazine. Okay, we get that is your phenyl that is your you are reacting with your hydrazine. Okay, hydrazine, we are going to get what? Hydrazone. This hydrazone further when we react it with KOH in the presence of ethylene glycol and when we heat it, we get hydrocarbons. Okay, we get hydrocarbons. So you have to practice. Okay. So unless and until you practice, you won't be perfect in that. Fine. Let us go. So these are the two important name reactions. Okay. So these two are there for your in your syllabus. Okay. Next we'll go for oxidation. So the last that is this is not there. Okay. So we'll not stretch much on this. So this is not there. So only these two you have to remember. Okay, with examples. Fine. Next one, oxidation. Okay, next we are going to do oxidation. So aldehydes and ketones, they easily get oxidized to aldehydes, they easily get oxidized to carboxylic acid. Okay, by we can use both. the strong oxidizing agent as well as weak oxidizing agent. Now, which are the strong oxidizing agents? So here is a list. Okay. So when we do oxidation on aldehydes, okay. So the strong oxidizing agents are like concentrated nitric acid, okay, potassium permanganate and potassium dichromate. That is HNO3, then potassium permanganate is KMNO4, potassium dichromate is K2Cr2O7. Okay. And mild oxidizing agents are your Tollens reagent and Fellings solution. Then Benedict's reagent. Okay, Benedict's reagent is also your mild oxidizing agent. So whenever we do oxidation on aldehydes and ketones, so aldehydes, they can go easily oxidation. Okay, it will undergo oxidation to give you carboxylic acids. Okay, it will give you carboxylic acids. Okay, so it can be differentiated by two oxidizing agents. So we can use strong oxidizing agents also and weak oxidizing agents also. So let us see some of the oxidizing agent reactions. Okay, and when we do so first, let us see the oxidation of aldehydes, okay, by using the weak oxidizing agents, that is Tollens reagent, how it reacts with Tollens reagent and how it reacts with Fehling solution. So aldehydes, okay, yes. So Tollens reagent is a important test. Okay, mark this as important test. So tolerance reagent is called as a ammonical solution of silver nitrate. So what is tolerance reagent? Tolerance reagent is called as ammonical silver nitrate solution. Okay, ammonical silver nitrate solution. And it forms a what? When aldehydes are heated with tolerance reagent. Okay, you take aldehyde, what you do? You heat it with what? Tolerance reagent. Heat it with tolerance reagent. Okay, it forms a bright silver mirror. Okay, it forms a bright silver mirror. Here you can see in the first picture. Yes, so this is the bright silver mirror. Okay, it forms like a metal. It forms like a metal. So due to the formation of silver metal, so like this, the black color like thing, silver mirror is formed. Okay. So what is happening here? Your aldehyde is getting oxidized to ion. Okay, it is getting oxidized to carboxylic ion. Okay, so this is the reaction. So this is the reaction. Aldehyde. Okay, your aldehyde when it reacts with the ammonical silver solution, silver nitrate solution in okay. Ammonical means ammonical will be this. So this is the ions or ammonical ions. Okay, then you get what? You get a carboxylic ion. You get a carboxylic ion. Okay, so this is a carboxylate ion, and so this is a silver ion. So the color, this is due to the precipitation of the silver. So this will be like shiny silver color. Okay, then this what happens? You get your silver mirror. So this will show you the silver mirror test. Okay. So what is the formula of tolerance reagent? Very important. Tolerance reagent formula. Please note it down. It can be asked as a question. So it is AgNH3 twice OH. Okay. So this is this your tolerance reagent. This okay. And both your aliphatic and aromatic aldehydes will show the tolerance reagent. Both aliphatic aldehydes as well as your aromatic aldehydes. So both these aldehydes will show you what? They will show you the tolerance test. Okay. So, and when we are distinguishing between aldehydes and ketones, suppose we have an unknown carbonyl group. Okay. And if we do the tolerance reagent, if it gives you a positive test, what it means? That it is a aldehyde. Okay. So aldehydes will show the positive test for your tolerance reagent. Ketones, they do not react with tolerance reagent. It will not react. So this will result like this. So it will be like this. So ketones will not react. Aldehydes will give you like the silver color test. Is it clear? So this is the tolerance test. So what you have to remember, what is tolerance reagent? It is ammonical solution of silver nitrate. Okay. So what is happening here? The aldehydes are reacted with tolerance reagent to give you a carboxylate ion, and it forms a silver mirror. Okay, it gives you a silver mirror. So what is happening? Your aldehydes are oxidized to carboxylate ion, and it gives you a bright silver color, a mirror like this. Okay. And whenever and only aldehydes will give you the positive test for tolerance test, and ketones, they do not give any positive test for tolerance. The aldehydes are they show the tolerance test. Okay. And what is the formula of tolerance reagent? The formula of tolerance reagent is your AgNH3 twice OH. Okay, so this is a tolerance reagent formula. So these things are important, very important. Okay, what you have to remember. Is it clear? Yes, tolerance test is clear. Okay, fine. So let us go for the next one. Next one is Fehling solution. Next one is Fehling solution. Okay. Now, what is this Fehling's test? Okay. What is this Fehling's test? So, Fehling's test, it is obtained by mixing two solutions. Okay. So, it is obtained by mixing Fehling's A, Fehling's A plus Fehling's B. Okay. Fehling's A plus Fehling's B. So by adding two different solutions of Fehling's A and Fehling's B. So Fehling's A is what? Copper sulfate solution. Okay, aqueous copper sulfate solution is Fehling's A. And what is Fehling's B? It is a sodium salt of, that is sodium potassium tartarate. Sodium potassium tartarate. Okay, that is called as Rochelle salt. It is called as what? Rochelle salts. Okay. So what is Fehling solution B? When alkaline sodium potassium tartarate is mixed with your aqueous copper sulfate solution, you get a Fehling's reagent. So what is Fehling's reagent? If they ask you, what you have to mention? You have to mention Fehling's A is aqueous copper sulfate solution, and Fehling's B is alkaline sodium potassium tartarate solution. That is Rochelle salt. Okay. So what is the reaction? You have aldehydes. Okay, you have a aldehyde. You react it with your Fehling's solution. You get a reddish brown PPT. You get a reddish brown PPT like this. Okay, you get a reddish brown PPT. So whenever you get a red, so this is a Fehling solution. Okay, when you add this is the aldehyde and your Fehling solution. Okay, so it will be blue color like. Okay, the Fehling solution is blue color. Sorry, this is a Fehling solution itself. So Fehling solution is what? It is blue color. To this, when you add aldehyde, okay, it becomes reddish brown precipitate like this. It gives you like this precipitate. Okay. So Fehling solution is blue in color. When you add aldehyde to this, you get a reddish brown color precipitate. Fine. So this is your Fehling's test. So remember, how is Fehling's test solution prepared? By mixing Fehling's A and Fehling's B. What is Fehling's A? Aqueous copper sulfate solution. Fehling's B is sodium potassium tartarate. Sodium potassium tartarate, or it is called as Rochelle salt. It is called as Rochelle salt. So both the tolerance reagent and Fehling solutions are used for this distinguishing test. Okay, and only your aromatic, that is your aliphatic aldehydes will show this test. Aliphatic. Whenever you have aliphatic aldehydes, only these will give the positive test. Okay, aromatic aldehydes will give you negative test. They do not show this test. Okay, and both the tolerance reagent and Fehling solutions, they will give you distinguishing test in aldehydes and ketones. So they can be distinguished well. Is it clear? So these are the two tests for aldehydes. So these are the two important tests for aldehydes, that is tolerance test and Fehling solution. So both these tests are important. Is it clear? Yes, everybody. So in today's class, so what all we have seen, just will recap. So I want you all to go through all the things. Okay. So today we have discussed the nucleophilic addition reaction. So we had just sum up all the things what we have discussed in the previous class. So we have started with the nucleophilic addition reactions. Okay. So we have seen the addition of hydrogen cyanide across the carbonyl group, then addition of sodium, this sodium sulfate solution. Okay. That is hydrogen cyanide, then sodium bisulfite. Okay. Then we have seen addition of Grignard reagent also in our previous class. Then we have seen addition of alcohols, right? Addition of alcohols. Then we have seen addition of ammonia and its derivatives also. So different derivatives, how they give corresponding products. Then we have seen reduction of alcohol. So whenever you have a carbonyl group, it will give you alcohol. So if you have aldehydes, it will give you primary alcohol. If you have ketones, it will give you secondary alcohol. So which were the reducing agents which we have seen? One is the sodium borohydride and the second was the lithium aluminum hydride. Sodium borohydride is a weak reducing agent and lithium aluminum hydride is a strong reducing agent. Then we have seen reduction with respect to this reduction on the carbonyl compound to give you hydrocarbons. So two important name reactions we have seen. The first was the Clemenson's reduction. In Clemenson's reduction, what we are doing, we have a carbonyl group. So carbonyl group in the presence of the reagents like sodium amalgam. Okay, that is zinc amalgam, not sodium amalgam. Zinc amalgam in the presence of concentrated HCl, we get hydrocarbons. So this was the Clemenson's reduction. And the second one was Wolff-Kishner reduction reaction. In that, what we are doing, aldehydes and ketones, we are treating it with hydrazine. Okay, with hydrazine, we are going to get a hydrazone. This hydrazone, we are going to heat it in the presence of ethylene glycol and potassium hydrogen, that is potassium hydroxide. Okay, we are going to get a what? We are going to get a hydrocarbon. So this also we have seen. Then we have seen the oxidation of aldehydes. So oxidation of aldehydes will easily get oxidized, okay, because aldehydes they get easily oxidized to carboxylic acid. So the two important tests for aldehydes are tolerance reagent and your Fehling solution. Okay, tolerance reagent, you get a silver mirror, and this test is only it gives you a positive test for only aldehydes. Ketones won't react for this reaction for this test, and both aliphatic as well as aromatic aldehydes will give you a positive test. Okay, then what is the tolerance reagent? It is ammonical silver nitrate solution. Then what is the formula? It is AgNH3 twice OH, right? So this is about tolerance. Then what is about Fehling solution? Fehling's test is made up of two solution, Fehling's reagent, Fehling's A and Fehling's B. What is Fehling's A? Aqueous copper sulfate solution. Fehling's B is alkaline sodium potassium tartarate solution, which is called as Rochelle salt. Okay, so these two are added in equal proportion. So, okay, so when you react the aldehyde with these Fehling's reagent, you get a reddish brown PPT. Okay, and only aliphatic aldehydes will give you a positive text. Aromatic aldehydes do not react. Ketones do not react. Okay, so this is the distinguishing test of aldehydes. Okay, so in the next class, we are going to see the oxidation of ketones. We are going to see oxidation of ketones. Okay, is it clear? Is it clear up to here? Okay, fine. So please, so you have to practice this name reaction. Okay, please practice this name reaction. So if you say now it is understood, but later in 1 or 2 days again you will forget. So practice is very important. So please write it and practice the reactions. Okay, because as you know, chemistry is a volatile subject. Okay, just for few minutes or few hours it will be in your mind, but later again it will get evaporated soon. So practice is more important. So you have to keep on practicing this name reaction. If you practice, then it will be fit in your mind. Okay. So if you see only once or twice, again after few days or few months, if you see it, it will be blank. Okay. You will forget the things. So you have to keep on practicing this name reaction. Okay. Fine. So the other things we shall be discussing in the next class. Okay. Any doubts? If you have any doubts, you can ask me, or you can go through the things, whatever have been told today, and you can ask your doubts tomorrow. No problem. Yes, anything you want to ask? Okay, fine. So by this, so we shall end the session here. Okay, we'll meet in tomorrow's class. Thank you. Have a good day. Yes.